Now it is time to find the trigonometric functional values of 135 degree, 225 degree. Let's now recollect the complementary angle formulae on trigonometric functions. 90 minus theta is the complementary angle. If theta is an acute angle, 90 minus theta, its terminal side will fall in the first quadrant. Now, regarding this 90 minus theta, we had some formulae. That was sin 90 minus theta, cos 90 minus theta, tan 90 minus theta, all trigonometric functional values on the 90 minus theta. And the formula went like this. Sin 90 minus theta is cos theta and cos 90 minus theta is sin theta. Its logic that is working behind, I'll be explaining little later. But this set of formulae you are already familiar with. Sin 90 minus theta is cos theta and cos 90 minus theta is sin theta. They turn to become the co-ratio. Sin function's co-ratio is cosine. Cos function's co-ratio is sine. Likewise, tan function's co-ratio is cotangent. We call it cot theta. And cotangent co-ratio is tan function. Cot 90 minus theta is tan theta. Similar relation between sec and cosec also. This is what one set that we are familiar with. But at this 90, pi by 2 radian, 90 degree. If you add theta instead of subtracting, we would have got an angle in the second quadrant, 90 plus theta. And there are going to be formulae based on 90 plus theta similar to it. A set of formulae is there. What will they be? We are going to see them. 90 plus theta, second quadrant angles. This set of formulae will be useful in calculating angles more than 90. Now, any angle whose terminal side is in the second quadrant can also be written as 180 minus theta. From pi, you subtract an acute angle. You get the angle whose terminal side is in the second quadrant, and like that also. That will look like this. That's again second quadrant angle. Pi minus theta or 180 minus theta. And we need to find the trigonometric functional values on 180 minus theta also. Not only 180 minus theta. We can have 180 plus theta also. That is pi plus theta. Of course, the terminal side will fall into the third quadrant now. Third quadrant. 180 plus theta will fall into third quadrant. Now, the third quadrant angles could have been written as 270 minus theta also. This is 270. From there you subtract. Again third quadrant angle. That will look like this. This is 270 or 3 pi by 2. From there you subtract a theta. You are back in the third quadrant. Even this set, this angle, this kind of angle will have all 6 trigonometric ratio formulae. Also, 270 plus theta will fall into the fourth quadrant, and fourth quadrant could have been written as 360 minus theta also. 360 minus theta again fourth quadrant, and also 360 plus theta in the first quadrant. We are going to have trigonometric functional values for all these kind of angles. Sin 180 minus theta, cos 180 minus theta, etc. etc. Sin 180 plus theta, cos 180 plus theta, etc. Not only that, for 270 minus theta, for 270 plus theta, for 360 minus theta, for 360 plus theta, all lot of formulae, so many of them. In fact, 48 formulae we need to remember. We had only 6 of them with us. But of course, if you're going to learn by heart all these formulae, it's going to be a tedious work. I'll give you a working rule. Only 2 steps it has. If you remember 2 steps, you will be able to handle all these 48 formulae. How? Step 1. Step 1 is, first of all, you decide the sign of the trigonometric function on the basis of the quadrant, whether it is positive or negative. This is what the rule. First quadrant, all trigonometric ratios are positive. First quadrant, all are positive. Second quadrant, only sine and cosec are positive. They are reciprocal to each other. Sine and cosec positive, rest all negative. Third quadrant, tan and cot positive, rest all negative. Fourth quadrant, cos and sec functions are positive, rest all negative. Let's apply this rule to all of them. Come on to it. This is second quadrant. Second quadrant, only sine and cosec positive. That means only this formula and this formula will have a positive value. Rest all will be negative. Pass on to this. This again is second quadrant. 180 minus theta. 180 minus theta again second quadrant. So sine and cosec positive, rest all negative. But if you go on to third quadrant, only tan and cot positive, tan and cot positive, rest all negative. Now, third quadrant here. In the third quadrant, we have tan and cot positive, and next all of them negative. Now pass on to fourth quadrant. In the fourth quadrant, cos and cosec positive, cos and sec positive, rest all negative. Fourth quadrant again we apply cos and sec positive, rest all negative. Again 360 plus theta means it's in the first quadrant, all will be positive. All of them positive like this. Now the first stage of the work is decide the sign whether it is positive or negative. Now step 2. Step 2 has two versions. Step 2 procedure will be some procedure for angles that are involving 90 degree and 270 degree. These are the two, 90 degree and 270 degree, whether it is 90 minus theta or 90 plus theta or 270 minus theta or 270 plus theta. For all of these four sets, the rule is the same. Whereas when the angles are involved with 180 and 360, these four of them, the rule will be something else. Let's go ahead with this. What's the rule? This rule you are already familiar with. What we already saw here. The functions are turning into their co-ratios. Tan turns out to be cot, cot turns out to be tan. Sine to cos and cos to sine. Like that here also in all four of them. Only difference is here we did not have to bother about the sign. All of them are positive. Here already we have fixed what are positive, what are negative, we have already fixed. Now you change the trigonometric functions into the co-ratios. So sine 90 plus theta, change it into cos theta. Already positive sign is already put there. So cos theta. Cos 90 plus theta, turn into sine theta. Already minus sign is there, so cos 90 plus theta is minus sine theta. Tan 90 plus theta will be minus cot theta. Cot 90 plus theta will be minus tan theta. Sec 90 plus theta is minus cosec theta. Cosec 90 plus theta is sec theta. Similarly here also, the rule is this. Change the trigonometric function into its co-ratio. Go on changing. Sine to cos, cos to sine. Tan to cot, cot to tan. Sec to cosec, cosec to sec. But whether they are to be positive or negative, already decide before changing. That's something to be taken care of. Don't wait for changing and then look for the signs. That may go wrong. Here also, sine to cos, cos to sine. Tan to cot, cot to tan. Sec and cosec also interchange. So these many formulae are ready now. Now let's see in the step 2 what we do with these angles. When the angles involved are 180 and 360, that means 180 and 360 are marked on the x-axis. X-axis angles. There, don't change. Keep the trigonometric function same. So if it is sine 180 minus theta, write sine theta only. Cos 180 minus theta, cos itself. Tan 180 minus theta, tan theta, of course with the minus sign that we had already fixed. So cot 180 minus theta minus cot theta, sec 180 minus theta minus sec theta, cosec 180 minus theta plus cosec theta. same thing go on doing for all of them. Don't change. Keep the trigonometric function the same. This is how we get trigonometric functional values which are written based on 90 degree, 270 degree, whether it is 90 minus theta, 90 plus theta, 270 minus theta, 270 plus theta. For all of them, change it to corratios. For 180 minus theta, 180 plus theta, 360 minus theta, 360 plus theta set. For all of them, no change. Keep the trigonometric function same as it is. Now let's see how we apply this working rule on numericals. Something like sine 150 degree. If we want to find out sine 150 degree, 150 degree can be written as 90 plus 60 degree. As 150 is 90 plus 60, the terminal side will be in the second quadrant. So I'm writing sine 150 as sine 90 plus 60. Now it is coming in this pattern. Since 150 is in the second quadrant, first of all decide what should it be, positive or negative. Sign is positive in the second quadrant. So give the positive sign. Then check the second step. When the angle is expressed using 90 degree, then change the trigonometric function into its coratio. So sine function will turn into cos function. So cos 60. Now what's the value of cos 60? That is half. So we get sine 150 degree equal to half. The same thing we could do in a different way also. 150 degree in the second quadrant could have been written as 180 minus something also. So sine 150 this time I'm going to write as 180 minus 30. Even that is 150 itself. Now look, 180 minus 30 also is in the second quadrant. 180 minus theta, second quadrant. So, depending upon the quadrant, we are going to assign the sign on it. That is positive. Why positive? Because sign is positive in the second quadrant. Then, since the angle is written using 180 degree, no change. Keep the trigonometric function same. So, sine 180 minus 30 is written as sine 30. So positive sine 30, that's equal to half. So whether you write it as 90 plus 60 and change the trigonometric function to cosine, or don't change by writing it as 180 minus 30, use sine function. Both ways you are getting the same answer for sine 150 degree. Let's have another example. Say sine 240 degrees. 240 degrees, it is more than 180, it goes into third quadrant. First I'm going to write it as 270 minus something. 270 minus what is 240? 270 minus 30 of course. Now this is a third quadrant angle. It looks like this. Theta is 30 degree now. Now sine function in the third quadrant. Sine function in the third quadrant cannot be positive. It has to be negative because in the third quadrant only tan and cot are positive. So you give the sign first, minus. Then, if the angle is written using 270, the ratio should change. So sine should change into cos. So cos 30. Now minus cos 30. What's the value of cos 30? It's root 3 by 2. So the answer is minus root 3 by 2. Now, the same 240 degree could be written using 180 plus 60. 180 plus 60 also is 240. This time, sine 180 plus 60, it is in this pattern, 180 plus theta pattern, third quadrant. 240 is anyway third quadrant. So, being in third quadrant, sine function is negative. Then, since it is written with respect to 180 degree, don't change the function, keep it sign. So it is minus sine 60. What is sine 60 value? Sine 60 is root 3 by 2. So minus of root 3 by 2. Both ways we are getting minus root 3 by 2 as the answer for sine 240. So either ways you can go, but the answer will be the same. Remember one thing. In case you are writing regarding 90 and 270 especially, first you put whether it is positive or negative depending upon the original function, not after changing it. Depending upon the original function, you decide whether it is positive or negative. Then you change or not change depending upon what angle you used, 270 or 180. This is how the numericals are done using this working rule. Now let's do some more examples like tan 90 minus theta, sin 90 plus theta, cos 180 minus theta, etc. These many let's do. Now, first one tan 90 minus theta. 90 minus theta is an angle in the first quadrant. 90 subtract theta. Being in first quadrant, the answer should be positive. All functions are positive in first quadrant. And since it is written with respect to 90 degree, when it is with respect to 90 degree or 270 degree, pi by 2 or 3 pi by 2, change the trigonometric function. So tan will be changed into cot. So the answer will be cot theta. Then sin 90 plus theta. 90 plus theta. 90 plus theta is in the second quadrant. Second quadrant sign is positive. So the answer will be positive. And also sign should change into cos. So positive cos theta. Now cot 180 minus theta. 180 minus theta. 180 minus theta is again in second quadrant. But cot will be negative. Only sign is positive. Cot is negative. 180 minus theta. 180 minus theta. So the answer will be negative. But this time, since it is written with respect to 180 degree, don't change. Cot will remain cot. So the answer will be minus cot theta. Come on. Sin 270 minus theta. Sin 270 minus theta. 270 is here. Minus theta makes it into third quadrant. Sin will be negative because only tan and cot are positive in the third quadrant. So the answer will be negative. Now also, since it is written with respect to 270, for 90 and 270, if the angle is written with respect to the y-axis angles 90 or 270, then change. So sin will change into cos. Since it is sin in the third quadrant, negative. So the answer will be minus cos theta. Next, tan 270 minus theta. Once more, 270 minus theta is in the third quadrant. Tan is positive. So the answer will be positive. Since we have written in terms of 270, change it into cot. So cot theta. Cos 90 minus theta. 90 minus theta, first quadrant. First quadrant all positive. Since it is with respect to 90, change it into sine, cos to sine. Therefore, sine theta. Then tan 180 minus theta, 180 minus theta. If it is from 180 minus theta, no change. 180, this is the angle. 180 also on x-axis. 180 minus theta, no change. Now, 180 minus theta is in the second quadrant. Second quadrant, tan is negative and no change. So the answer is minus tan theta. Cos 90 plus theta. 90 plus theta. Second quadrant, cosine negative, minus, but cos has to change into sine. So minus sine theta. Next is sine 360 minus theta. 360 again is x-axis one. 360 minus theta. Fourth quadrant. In the fourth quadrant, sine is negative, but no change. So minus sine theta. These are all for variable theta. Now let's go for some numericals. Cos 150, cos 135, sin 120, etc. numericals. This time we have the freedom. 150 can either be written as 180 minus 30 or 90 plus 60. Both are okay, as you wish. Okay, 150 minus theta. I am going to write it as 180 minus 30. Since it is 180 minus 30, it is in the second quadrant. Cosine will be negative and cos I am not going to change. Because I am going to write it as 180 minus 30, so it will be cos 30 but with the minus. Minus cos 30. And what is cos 30 value? That is root 3 by 2. So the answer is ready, minus root 3 by 2. Cot 135 degree. 135, second quadrant. I am writing again as 180 minus 45. 180 minus 45. I am choosing 180 because I do not want to change 180. So cot will remain same. So in the second quadrant, since cot is negative, the answer will be minus cot 45. That is minus 1. Next is sine 120. 120. I have the option of writing it as 190 plus 30 or 180 minus 60. I am going by 180 minus 60 so that I do not have to change the trigonometric function. 180 minus 60 is better for me. So 180 minus 60, second quadrant, sine is positive. So it will be sine 60. Sine 60 is root 3 by 2 and that was positive because of second quadrant sine. Tan 225. 225 goes into third quadrant. Third quadrant, tan is positive. And I would again write it as 180 plus 45. I would prefer to choose 180 to avoid changing. So tan 180 plus 45 will be tan 45, that is equal to 1. Positive because third quadrant. Now cos 240. Cos 240. 240 is again in the third quadrant. Third quadrant, cosine is negative. 180 plus 60 it is. So negative cos 60. So minus half. Sin 300. 300 is in the third quadrant, which I am going to write as 360 minus 60. 360 minus 60. That is sin 60. But remember, sin is negative in the fourth quadrant. So minus sin 60. So minus root 3 by 2. Sec 210. 210 is 180 plus 30. So 180 plus 30, sec, no change. But sec is negative in the third quadrant. So minus sec 30. Sec 30 is reciprocal of cos 30. So 2 by root 3. Cos 330. Cos 330. 330 is in the fourth quadrant. Why not we write it as 360 minus 30? 360 minus 30. Cosine is positive. So it will be positive cos 30. Cos 30 value is root 3 by 2. Sin 135. 135. Second quadrant. Second quadrant sine is positive. So 180 minus 45 I would write for 135. So sin 45, which is positive, 1 by root 2. Let's go for many more like this. This is for you to enjoy. Then start writing them using the radian measure also. The same rule. You should be familiar. 3 pi by 4 is equivalent to 135 degree. 5 pi by 30, 5 times 60, 300 degree. 5 pi by 6, 5 into 30, that is 150 degree. 2 pi by 3, 2 into 60, 120 degree. 11 pi by 6, 11 times 30, 330 degree. 5 pi by 4, it is 225 degree. 7 pi by 6, 210 degree. You need not go into degrees. You start doing it in terms of the radians only. We will do in the next session that. Or you may try these working rules. You may try on all of them. And the answers you can cross check. Let's consider some general cases now before we bring down the shortcut method. Any angle in the second quadrant. Any angle in the second quadrant, if you want to find sine of any angle in the second quadrant, we may write it as sine 90 plus theta or sine 180 minus beta. 90 plus theta or 180 minus beta, either of these. As we already observed in these numericals. Now, if this is the one we are going to follow, apply sin A plus B formula. Sin A cos B plus cos A sin B gives you sin 90 cos theta plus cos 90 sin theta. Give the values. Sin 90 is 1, cos theta as it is copy down, cos 90 is 0, sin theta as it is. Now, this term is altogether 0 and this is cos theta equal to cos theta. Here, Sin 90 plus theta has become cos theta. A similar formula you had earlier also, sin 90 minus theta is cos theta we had. It looks very similar. Okay, we'll go ahead. Let's calculate the other one and come. Sin A minus B formula says sin 180 cos beta minus cos 180 sin beta. A is 180, B is beta. Sin 180 is 0, cos beta as it is, minus. Cos 180 is minus 1 into sin beta. Minus of minus positive, so this term is sin beta. Now, here sin 90 plus theta is cos theta, sin function changes to cos theta. But here, sin 180 minus theta, no change in the function, sin remains sin. What is happening here? Okay, we'll come back to it. Let's observe one more. Same angle, second quadrant angle. This time we are going to do cosine on it. Cosine of second quadrant. So we will do cosine of 90 plus theta or cosine of 180 minus beta. Angles are the same. Instead of sine, we are doing cosine. So cos 90 plus theta will follow cos A plus B formula. Cos A plus B is cos A cos B minus sin A sin B. Give it. Cos 90 cos theta minus sin 90 sin theta. Values. Cos 90 is 0 into cos theta minus sin 90 is 1 into sin theta. So this part is 0, this is minus 1. Minus 1 into sin theta is minus sin theta. Here what's happening? Cos 90 plus theta, okay, it is changing into sin. But there is a minus sign coming up. Okay, let's go for the next one. Here also cos 180 minus 1 cos beta plus sin 180 is 0 into sin beta gives you minus cos beta. Minus is happening here also. But cos is not changing. What is it as a whole? Altogether, it is bit of confusion it looks. Sometimes sin changes to cosine. Sometimes sin doesn't change to cosine. Sometimes cos changes to sin, but minus sign is coming up. And here cosine doesn't change, but sin minus sign comes up. To understand this confusing situation, in fact, you just need to know working rule of it. Only 2 steps. If you just have 2 steps, you will be able to write any of these angles, sine or cos or any other trigonometric function. How is that? Let's go ahead and see.